Hi folks, today I have another lesson for you about a phase change question, a question in which a substance is changing phases. Usually it is when we get a question about phase change, it is the change in phase of water. So let's look at an example here. So over on top, I have just provided two pieces of information, which is usually critical when you have a change in phase. Heat of vaporization, which is the change of a liquid into a gas, and the amount of energy required for every mole of water to change from liquid to a gas is 40.67 kilojoules of energy. In other words, heat of vaporization is 40.67 kilojoules per mole. The second heat is heat of fusion. And the heat of fusion is when you have a solid converting into a liquid, the change of phase from a solid to a liquid. And in this case, the amount of energy is 6.01 kilojoules per mole. Again, we don't use both the piece of information and the same question, but you might as well have both the values present here. So I have provided both that piece of information. So those pieces of information are here. And let me just highlight that for us. We have the heat of vaporization, and I have the heat of fusion. All right, getting back to the question. Now, the question over here we have is how many joules, which is energy, so how many joules of energy are required to heat 200 grams of water? So we have 200 grams, which is the mass of the water, from 25 degrees Celsius to 125 degrees Celsius. In the first glance, it looks like we can just use Q is equal to mc delta T. We have the mass of the water. We know the specific heat capacity of the liquid water, which is 4.18 joules per gram degree Celsius. And we know that the temperature change over here is about 100 degrees Celsius. But before we proceed, we have to realize that water boils at 100 degrees Celsius. That means it does not stay in the liquid state after 100 degrees Celsius. It actually converts into a gas, in this case, a steam. And therefore, the specific heat capacity of steam, which is not the same as the specific heat capacity of liquid water. The specific heat capacity of steam is given to us as 1.84 joules per gram degrees Celsius. So we will have to use that to figure out how much energy is required to change the temperature of the steam from 100 degrees Celsius, when the steam is originally formed, to 125 degrees Celsius, which is our final temperature. So, before we start solving the question, I just want to draw a diagram to explain where we are and what energy components we need to calculate. So initially, we will have our temperature of the water over here, let's say at 25 degrees Celsius. What we will do with this temperature is we are going to heat this temperature water up. So it's going to heat until it reaches 100 degrees Celsius. So this point is now going to be 100 degrees Celsius, right? And this process is going to take energy, right? So going from 25 to 100, this will absorb energy, and we will have to calculate that energy. Let's say this energy is Q1. Okay, so we'll have to calculate this amount of energy, which is going to be labeled as Q1, and we are going to solve for it in just a moment, but we want to figure out all the energies that we have to add up to get the total amount of energy. The second part, so after the water has changed temperature from 25 degrees Celsius to 100, we are going to continue to apply more heat. But this heat now is not going to be used to change the temperature of the water. It is, on the other hand, going to be used to change the phase of the water. So the substance is going to change from a liquid to a gas, and when this happens, the substance stays at the same temperature. And what is happening here from this point, the initial point here, let's say this is point A, point B, point C. So what's happening from point B to point C is the temperature is being maintained at 100 degrees Celsius. But what we have is we have liquid water, so this is water, converting into steam. And when this phase change is taking place, the temperature does not change. The temperature is maintained at 100 degrees Celsius. Once the water has been converted into steam, we have to apply more energy because our final temperature we have to reach is 125 degrees Celsius. So we have to apply more heat, and now once we apply more heat, the temperature is going to start to rise and it's going to hit 125 degrees Celsius. And this is going to be the temperature of the steam now. So we have labeled Q1 as the change in temperature of the water from 25 to 100. Let's say the change of phase, the amount of energy required for that is Q2. So the amount of energy required between B and C is Q2. And let's label the last point as D. The amount of energy required to change steam, which is at 100 degrees Celsius, point C, to steam at 125 degrees Celsius is, let's say, Q3. Okay, so we have three different Qs here. We need to calculate Q, the amount of energy required to change the temperature of the water from 25 to 100. Then we need Q2, which is the change of phase. So the temperature is going to stay the same, but the phase of the substance is going to change. It's going to change from a liquid to a gas. And Q3, which is the change in temperature of the steam going from 100 degrees Celsius to 125 degrees Celsius steam. And once we have all of these three Q values, we can add all of them up to find out the total amount of heat that is required to change the temperature of 200 grams of water from a 25 degrees Celsius to 125 degrees Celsius. Okay, so now we have the question established. Let's now solve for the answer. Let's calculate Q1. So Q1 is the amount of energy required to change the temperature of the water from 25 to 100 degrees Celsius, which we are going to use the formula mc delta T. Mass of the water is 200 grams. Specific heat capacity of water is 4.184 joules per gram degrees Celsius. And the change in temperature is 100 minus 25 degrees Celsius. And now, once we calculate this, we get a final answer of, again, I'm going to have to use my calculator to find this out, 200 times 4.184 times 100 minus 25, which is 75. And I have an answer of 62760. 62760 joules of energy. All right, so 62760 joules of energy. So 62,760. Okay, so that's Q1, and I'll label that as Q1. We have found Q1. That's first part of the energy. So this is the amount of energy required to change the temperature of the water from 25 degrees Celsius to 100 for this 200 gram water. Now let's look at Q2. So in the case of Q2, there is no change in temperature. To figure out amount of energy required here, we have to find the moles of water that we are using times the delta H of vaporization, the amount of energy required to convert or change the phase of water to steam. And that is the heat of vaporization, which is given on top, which is 40.67 kilojoules per mole. So the amount of moles of water that we have is a mass, which is 200 grams, divided by 18.02 grams per mole, which is the molar mass of water. And if you take that and multiply by the delta H value, which is 40.67 kilojoules per mole, this will give us the amount of energy that is required to change the phase of 200 grams of water from liquid to a gas. So I'm just going to calculate that right now. So 200 divided by 18.02 multiplied by 40.67. And that results in an answer of 451.387. And this unit is kilojoules because the moles and the moles will cancel out, the grams and the grams will cancel out, and since the energy was given in kilojoules per mole, the answer over here is 451.387 kilojoules, and I'm using a few extra digits right now. Okay, so I was using about 5 digits to 6 digits here for my calculation. So first value I have is Q1 in joules, second one I have in kilojoules. We can convert one into the other. And the third energy that we have, Q3, is the amount of energy required to change the temperature of the steam from 100 to 125. And for this part, we can use mc delta T again. And the mass of the steam is 200 grams. The steam's mass is not going to change. The specific heat capacity of steam is 1.84 joules per gram degrees Celsius, and the change in temperature is 125 minus 100. The 25 degrees Celsius that we have to go above, right? And so once we have the equation, we can plug all these values in, which are 200 times 1.84 times 125 minus 100 is 25. So I'll multiply it by 25 and I will get an answer, or I have an answer of 9200 joules of energy. Okay, so I have now Q1, Q2, and Q3. So total energy, total heat of total is equal to Q1, which is changing the temperature of the water from 25 to 100, plus Q2, which is changing the phase, plus Q3, which is changing the temperature of the steam from 100 to 125. Adding all of the three values together, we get 62760 joules. Plus, since we have this value in kilojoules for Q2, we can convert into joules. We get 451.387 joules. Plus, we have 9200 joules. So now we have all the values in the same units. We have all of them in joules, and we can now add them up. 62760 plus 451.387 plus 9200, and that gives us the total amount of energy that is required, which is 5,233,47 joules. And again, because this is a very big number, we can convert it into kilojoules, and so kilojoules would become 523.347 kilojoules of energy. And if you are looking at significant figures, the values we had were 3 significant figures, so I'm going to round it off to 3. So 523 kilojoules of energy. So this is the total amount of energy that was required to convert 200 grams of water from 25 degrees Celsius to 125 degrees Celsius.